Hello everybody! In this video I will introduce the theorem of Pythagoras to you and we will discuss 5 examples. Before we get to the theorem of Pythagoras, I want to show you that, remember, the side opposite the right angle is called the hypotenuse. Then when you have angle A, the side opposite angle A, we can label it as little a. The side opposite angle B is little b, and the side opposite angle C is little c. Now we can say the theorem of Pythagoras is always the hypotenuse squared is equal to one side squared plus the other side squared. And then you can write this in terms of A, B, and C for this triangle as C squared equals A squared plus B squared. We can also say that if that's your theorem of Pythagoras, maybe you want to make A the subject of the formula. Then the B squared can walk across and you end with A squared is equal to C squared minus B squared. And again, there's your theorem of Pythagoras in standard form. Maybe you want to make B the subject of the formula. Then you can write B squared in terms of C squared minus A squared. Now, before we start with the actual sums, I just want to show you there's something we call Pythagorean triplets. So in a right angle triangle, you get, if this side is 3, this side's length is 4, then the hypotenuse length is 5. So 3, 4, 5, you call that a Pythagorean triplet. There's more. If this side's length is 5, this one is 12 and the hypotenuse will be 13. So 5, 12, 3, 13 is a Pythagorean triplet. And another one, 8, 15 and 17. Example 1. Calculate the length of the third side in triangle KLM. So we always start, when we work in a right angle triangle, with the theorem of Pythagoras as hypotenuse squared is equal to one side squared plus the other side squared. So in terms of this triangle, it will be km squared is equal to KL squared plus LM squared, and we always add Pythagoras. Now we can substitute. In KL's place, 4 squared plus LM's length is 3 squared. 4 squared plus 3 squared. Let's see. 4 squared means 4 times 4, which is 16, and 3 squared means 3 times 3, which is 9. 16 plus 9 is 25. And then we don't want km squared, we only want km. So to get rid of the square, we will take the square root both sides. But remember, when we take the square root, then I just want to show you we add plus minus. But for us now in grade 9, it's not necessary. You can just take the square root. And then the square root of 25 will be 5. And what happens here is you drop the square root. Therefore, km is equal to 5 units. Example 2. Calculate the length of the third side in triangle ABC. Now when you go to triangle ABC, you will see that AC, the hypotenuse, was given and one other side. But my advice to you is always start with the basic form of the theorem of Pythagoras, as in hypotenuse squared is equal to one side squared plus the other side squared. And then in terms of this triangle, it will be AC squared is equal to AB squared plus BC squared, and you always add the reason Pythagoras. Now you must substitute. So in AC's place, this is the hypotenuse. 50 squared equals AB squared is the one you're looking for, plus BC was 48. And remember to use brackets. Then you can say 50 squared means 50 times 50, which is 2,500, equals AB squared plus, and 48 squared is the same as 48 times 48, which is 2,304. Then let's let that one walk across. 2,500 minus 2,304 is 196, equals AB squared. To get rid of the square, we take the square root both sides, and the length of AB is 14 units. Example 3. GH is 6 meters. HJ is 8 meters. FG is 26 meters and FJ is little y meters. Calculate y. Now, when you look at your two triangles, it's very clear that y lives in triangle FGJ. But it's a right angle triangle, but unfortunately we don't know the size of JG. But when we go to the other triangle, GHJ, we can work out the length of this. This will be the hypotenuse, JG, of this other triangle. And since it's a right angle triangle. So what we will do is we will work out the length of JG, and then we can move over to the other triangle. So it's a double whammy Pythagoras. Let's see. With Pythagoras, we always start. Hypotenuse squared is equal to one side squared plus the other side squared. So now I'm working in triangle GHJ, and I can write it as GJ squared is equal to GH squared plus JH squared, and your reason, Pythagoras. Now we can substitute. GH is 6 squared plus JH is 8 squared. 6 squared means 6 times 6 is 36, plus 8 squared means 8 times 8, which is 64. 36 plus 64 is 100. And then on the left hand side you have GJ squared, but you want only GJ, so you will take the square root both sides, and then GJ is 10 units or meters in this case. So in flies the size there. Now we can move over to triangle FJG, and again the theorem of Pythagoras is the hypotenuse squared, which is FG squared, is equal to FJ squared plus JG squared, and you also write Pythagoras. Now we can substitute. FG is 26 squared equals FJ is y, that's the one we're looking for, plus JG squared, which is 10 squared. 26 squared means 26 times 26 is 676, equals y squared plus, and 10 squared is 100. Let it walk across. 676 minus 100 is 576, equals y squared. Take the square root both sides, and then y is equal to 24 meters. Before we continue, have you subscribed yet? Or you can like this video, and better yet, please tell your friends about my channel. Let's continue. Example 4. O is the center of the circle with angle C1 equals angle C2 equals 90 degrees. So quickly go to the sketch. This implies that triangle DOC and triangle OCE, they are two right-angled triangles. The question says, determine the length of the diameter of the circle. Now, can you see they want the length of the diameter? So where on earth? Where do you find a diameter? A diameter is twice the length of the radius. So now, if only we know the size of the radius, we can double it and then we find the diameter. So how will we find the length of the radius? By using the theorem of Pythagoras. Can you see, this is how you do maths. You break your problem up into little steps. So let's start. Hypotenuse squared is equal to one side squared plus the other side squared. Therefore, the hypotenuse is OD squared is equal to OC squared plus CD squared Pythagoras. Then OC is 12 squared plus DC is 9 squared. 12 squared means 12 times 12, which is 144, plus 9 squared means 9 times 9, which is 81. 144 plus 81 is 225. We take the square root both sides and OD is equal to 15. So now we know the size of the radius. What was the question? Find the length of the diameter. So a diameter is 2 times the radius. Therefore, 2 times 15, which is 30 units. Example 5. Calculate the value of little x to 2 decimals if y is 5 and z is root 15. Now, where do we find little x and little y? Let's see. Little x is the side opposite angle x. Little y is the side opposite angle y, and little z is the side opposite angle z. Furthermore, it was given that y is 5 and z is root 15. So let's work out little x with the theorem of Pythagoras. Always, hypotenuse squared is equal to one side squared plus the other side squared. And then in terms of this triangle, y squared is equal to x squared plus z squared. And we have to add Pythagoras. Now we can substitute in y's place 5 squared equals x squared plus, and in z's place root 15, and we square it. Now I want to show you here root 15 squared. A square root is the same as to the power of a half squared, and then 2 goes in itself once, 2 goes in itself once, and you're left with only 15. So therefore, root 15 squared is just 15. Back to our sum. 5 squared, 5 times 5 is 25, equals x squared, and root 15 squared is just 15. 15 walks across. 25 minus 15 is 10, is x squared. Take the square root both sides, and x is equal to 3,16. In the next lesson, I will teach you how to determine if a triangle is a right-angled triangle. Click on the video in the left-hand corner to take you straight to the next video.